Okay, so let's keep going. We'll do another example. Here we go. So here's another example we can do. Okay, so here, it looks like at first, it's going to be kind of complicated, right? We have three terms. The leading coefficient is not 1, right? And in that case, you might be thinking, well, let's do the AC method, because we're factoring. But let's see if we could try factoring out the GCF. Although in the AC method, you have to take out the GCF anyway, the greatest common monomial factor. So again, it's already in standard form, right? Again, we have the polynomial equal to 0. Now, with factoring, it's always good to get the GCF first, and factor it out anyway. Make sure am I recording? Okay, good. All right. So again, that GCF as before, right? It's bx to the m. There's a non-zero constant term here, right? We can't factor out x. X is not in every term. So the GCF won't have an x in it. Or we could take m to be 0, same idea. Notice that 2 is a coefficient, it's the leading one, and 2 is a factor of the other coefficients and constant term. What I'm trying to say here is 2 is itself b, so that is 2 is the greatest common factor of the coefficients and the constant term. If you were to list the factors of 2, 10, and 12, 2 would be the greatest common factor. And so our GCF is this, 2x to the 0, which is just 2. So now that we have the GCF, let's factor it out. And that's what I'm doing here. I said this for the, oh, sorry, I don't want to. I also did say this for the other class, on a quiz or test, I'm showing more steps. I'm showing all the steps because, again, I don't know everyone's math background here. So I err on the side of caution. But if you were to say to skip this step here on a quiz or test, that's fine. I know that, I understand the tests are open book and open notes. There's still a time limit though. Okay? But you just want to make sure you show enough steps so that I know that you know what you're doing. So if you were to skip this, let's say, and you had this directly to here, that's fine. Okay. You don't want to just write the answer because you want to show some work. So, all right. So we have the GCF, which is 2. We factored it out, right, by dividing, as you can see. So really then what's left is to factor this polynomial, x squared plus 5x plus 6. Now, to factor this, notice that we have 3 terms, the degree is 2, and the leading coefficient here is 1, right? 2 is outside. So to factor the inside here, we want 2 numbers whose product is 6, the constant, and whose sum is 5. So we want 2 numbers whose product is 6 and whose sum is 5. That's what we're looking for. Okay, what 2 numbers are going to pull that off? We could probably guess that the numbers are 3 and 2, as you can see. Okay, so 3 and 2 are the numbers, and because they are the numbers, right, we have this. X squared plus 5x plus 6, that becomes x plus 3 times x plus 2. Okay, so we have x plus 6 times, we have x plus 3 times x plus 2. And so putting it all together, right, this is what we get. We have 2 times this product equal to 0. So now that we have factored it, right? That's our second step. Next, we're going to set each factor equal to 0. Let me just erase that. Well, actually, I guess I can't. That's all right. We're going to set each factor equal to 0, and from each one, and by doing that, we're going to solve each individual equation. If you were to set 2 equal to 0, right, that wouldn't make sense. 2 can equal to 0, right? That's why I put this x here in red, just to illustrate that. I don't think I can erase it, but just to illustrate that 2 can equal to 0, so really we can ignore that factor. We do have x plus 3 equal to 0 and x plus 2 equal to 0. So from these factors, we have an equation to solve. That's our first one, right? That's our first one, x plus 3 equal to 0, right? And so from there, we want to get x, right? We want to isolate x, get x all alone. So we subtract 3 from each side, and we get x is minus 3. From the other equation here, same idea, right? We want x all alone, so we subtract 2 from each side. Doing so, we get x is negative 2. And so we have our two solutions, negative 3 and negative 2. Okay. And again, it's good to check. So that's what I'm doing here. You know, it's good to check if you can. So that's what I'm doing. You know, I'm replacing x by those numbers in the original equation, and it does turn out that the equations hold. That is, when you replace x by the numbers, you get true statements. All right. So that's what we have here. Okay. Now, so this was solving a quadratic equation by factoring. As I said before, there are other methods we can use to solve a quadratic equation. The other one we're going to deal with is the quadratic formula. I mean, this is nice in that it's going to work no matter what quadratic equation in standard form you have. So even if you have one that's very hard to factor, this formula will help you. But factoring is still good to do. So if you have the equation in this form, you have to have it in this form. That is, you have to have this equal to 0. Okay, because otherwise this formula is not going to help you. Solutions to this equation here are going to be given by this. Keep in mind, A, B, and C are numbers, so they're constants, and A is not 0. I mean, I've seen people in the past, what they would do in the formula is they would replace B here with B times X. So you would have X in this formula. Don't do that. A, B, and C are numbers. Now, there are two solutions here, right? Here you have addition, negative B plus this stuff. Here you have negative B minus this stuff, right? Well, people usually write that in a more compact way. They do this. You have negative B. This means plus or minus this over 2a. So this is more compact notation for these two things. That's all. Notice also that we're dividing the entire top here by 2a. I've seen people in the past, they would just have negative b plus or minus this thing over 2a. Basically, you want the entire thing here over 2a. Hope that makes sense what I'm saying. But anyway, that's the quadratic formula. You know, you don't have to memorize it. You just want to make sure you know how to use it. I mean, even if I were teaching in class and not virtually, I would, give everyone the formula. I care more about that you know how to use the formula. So, all right. Okay, so that's the quadratic formula. Let's do some examples. So here's our first one. We're going to solve that equation using the quadratic formula. Now notice this is already in standard form, right? You have something equal to 0. Okay, so we can use the quadratic formula. We just have to figure out what A, B, and C are. But you can see that by comparing coefficients. The leading coefficient is your A, okay? The coefficient of X is your B. The constant term is your C. But you must include the minus sign when you're subtracting. That's what we're doing here. So we have our A, B, and C. Remember, you include the minus sign, okay? Make sure you do that. Now that we know what A, B, and C are, we can use the formula. And that's what I'm doing here. I'm just replacing, A with the number A is, B with it, and C with it. Okay, B is positive 4, but here we have negative B. That's where the negative 4 comes from. Here we have 4 squared minus 4 times A times C is negative 4, right? That's why we have a minus 4. So this would really be 16 minus negative 48, but minus a negative is plus. So we have this. And if you add 1648, you actually get 64. 64 we know is a perfect square, right? And on the bottom, I forgot to say this, 2 times A is 3, so we get 6. 64 is a perfect square. 64 is 8 squared. So we actually have the square root of 64, which is just 8. And that's how we get from here to here. But there are 2 solutions here, okay? We have negative 4 plus 8 over 6 and negative 4 minus 8 over 6. That's what we're doing here. So as you can see, here we have negative 4 plus 8 over 6. That's just 4 over 6, right? Which is 2/3. Again, if you left it as 4 over 6, that's fine. I didn't go into like writing fractions in lowest terms. So, I mean, I hope you know how to do that already. But for now, you could just leave it as 4 over 6. You don't have to simplify unless I tell you to, is what I'm saying. And for this one, if you subtract, you get negative 12 over 6, which is negative 2. Those are our 2 solutions here. Okay. All right, let me pause the recording. Okay.